Good morning. This is Professor Shannon Gracie. Today we'll be covering section 9.1, and we're working out of Blitzer's textbook, Introductory and Intermediate Algebra for college students. So we'll be reviewing how to solve linear inequalities and using linear inequalities to solve problems involving revenue, cost, and profit. So let's warm it on up by solving this linear equation in one variable. All right, so pause the movie, warm it up, and we'll see how you did. Okay, let's see how you did. We need to distribute that -8. So -8 times 12 gives us, I believe, -96. And then -8 times -5x is plus 40x. That's all equal to x. 5 minus 96 is -91. If I add 91 to both sides and subtract x from both sides, I will have 39x is equal to 91. And then dividing both sides by 39, we will have x is equal to 91/39, which I believe is reduced. So we get a single solution of 91/39. How'd you do? All right. Okay, moving right along. So the steps for solving a linear inequality. This is a review from section 2.7. If you need like more in-depth stuff, you can go to section 2.7 on my beginning algebra site or introductory algebra site and watch that movie. So what you do is you simplify the algebraic expression on each side. Use the addition property of inequality to collect all the variable terms on one side and the constant terms on the other. Use the multiplication property of inequality to isolate the variable and solve. You need to change the direction of the inequality when you do what? Good. Multiply or divide both sides by a negative number. And then you would express the solution set in interval notation and graph the solution set on a number line. So the only time you wouldn't do interval notation is if there was no solution. Then you would just do your set notation. Okay, so solve and graph the solution on a number line. So first off, we could subtract 5 from both sides, and we'll get 2x is less than 12. And now dividing both sides by 2, we get x is less than 6. So if we want to do the graph first, that means that x is smaller than 6, so to the left of 6. So basically we're going like this, and we're shading everything that's going to be to the left of 6. And then we have to decide what we're going to put around the 6. So we basically need the equivalent of an open circle, which is the parenthesis. So in interval notation, the solution is minus infinity to 6. And you're done. Okay, so part B. At any time, feel free to pause the movie and try these problems yourself, or you can just follow along with me. So for this guy, we need to distribute that -4 through that binomial x plus 2. So we'll get -4 times x minus 8 is greater than or equal to 3x plus 20. So we want the x's on one side and the constants on the other. So if I add 8 to both sides, and then if I take away 3x from both sides, I will have the x's on the left and the constants on the right. So I'll get negative 7x is greater than or equal to 28. Now dividing both sides by a negative, so be careful. We have to change the direction of the inequality, so x will be less than or equal to negative 4. So that means that x is infinitely to the left of negative 4. So we've got that going on by the arrow. And now we have to decide what ending. So we want to include negative 4 in the solution. So we do the bracket. In interval notation, we'll have minus infinity to negative 4 with the bracket around the negative 4. Remember that infinity and negative infinity always have the parentheses around them, and negative infinity is always the leftmost item in there, and if you had positive infinity, it always has to go on the right side. Okay, so moving right along, we have this next guy. Why don't we go ahead and multiply both sides by the LCD, which is 12. That will clear the fractions. But be careful on the left side. That's going to give us 12 times 4x minus 3 over 6 plus 12 times 2 is greater than. Now on this side we can divide out because we only have one term, and we'll get 2x minus 1. So now we'll have 6 goes into itself once and into 12 twice. So we will have 2 times 4x is 8x minus 6 plus 24 is greater than 2x minus 1. 8x, if I combine the negative 6 and the 24, we'll get 8x plus 18 is greater than 2x minus 1. Getting the constant on the right side by subtracting 18 and subtracting 2x from both sides to get the variable on the left. We have 6x is greater than negative 19. Dividing by 6, we'll have x is greater than negative 19 over 6, which is about negative 3 1/6. So this time x is good, it's larger, so it's to the right. So negative 3 1/6 is about here. And so I'm moving to the right. And then I have to decide what ending to put on it. So it's a greater than, so we put the parenthesis around it. So and our solution in interval notation will be negative 19/6 with the parenthesis all the way to infinity. Oops. And that's our solution. How we doing? Awesome. Okay, so now this one, a little more complicated looking. We have, we basically have f at x equal to, this one algebraic expression, and g at x is equal to another. And we want to find all values of x for which g at x is less than or equal to f of x. I know it looks really scary, but all you do is you write the expression that g of x is equal to, which was the 3/8 times 16 minus 8x, and then minus 7, and you set that less than or equal to the expression that f at x is equal to, which was 2/5 times 10x minus 15, and then plus 9. And then you solve it and graph the solution. So we'll have, remember we have to distribute, so we'll have 3/8 times 16 minus 3/8. Let me write that a little differently. 16 is like 16 over 1. And then minus 3/8 times 8x over 1. Then we have the minus 7 is less than or equal to 2/5 times 10x over 1 minus 2/5 times 15 over 1, and then plus 9. So 8 goes into itself once and into 16 twice. So we'll have 3 times 2 is 6 minus the 8's divide out, but don't forget that x is still there. So we'll have minus 3x, and then minus 7 is less than or equal to 5 goes into itself once and into 10 twice. So we'll have 4x, and then minus 5 goes into itself once and into 15 3 times. So we'll have minus 6 plus 9. So we'll have negative 3x minus 1 is less than or equal to 4x plus 3, which will give us, let's see what we need to do. We need to add 1 to both sides and subtract 4x from both sides. And we will have negative 7x's is less than or equal to 4. And be careful, we're dividing by negative 7. So we have to change the direction of the inequality to greater than or equal to negative 4/7. So negative 4/7 is a little to the left of negative 1/2. And x is greater than or equal. So it'll be about here. We'll be going to the right. And what ending should I put on that? Good, I should put a bracket because we're including negative 4/7 in our result. And that is the answer. Okay, so now we get into functions of business and linear inequalities. So for any business, the revenue function, which is denoted by R at X, is the money generated by selling X units of the product. So in general, revenue at X is equal to the price times the number of units sold. So this is the P is the, I'll write it over here. P is the price per unit. And X is the number of units produced. So we'd have X units produced. Okay, and the cost function, which is denoted C at X, is the cost of producing X units. Actually, I'm sorry, let me go back here. In this case, it's not X units produced, it's X units sold. Okay, for the revenue function. Now for the cost function, what happens is you get this cost function in X, and that's going to be equal to whatever the startup or fixed cost is. And then you have to add the the cost per unit. It costs money to produce each unit. And then you have to multiply that by the number of units produced. So C, lowercase c, is the cost per unit. And there are X units that are made or produced. So this C is how much it costs to make each unit. Okay, so the term on the right, which is CX, C, lowercase c times X, represents variable cost because it varies based on the number of units produced. And fixed cost is a one-time cost. So revenue, cost, and profit functions. So a company produces and sells X units of a product. So the revenue function is R at X equal to the price per unit sold times X. The cost function is the fixed cost plus the cost per unit produced times X. Now the profit function would be all the money you take in minus the money it costs to make that number of units. So it turns out that the profit function is equal to the revenue function minus the cost function. So let's take a look. A company that manufactures bicycles has a fixed cost of $100,000. It costs $100 to produce each bicycle. The selling price is $300 per bike. Let X represent the number of bicycles produced and sold. So let's write our cost function first. So the cost function, what is the fixed cost? Good, $100,000. And then each bicycle costs $100 to produce. And we'd multiply that times X. Now the revenue function, they're charging $300 per bike. So the price, 300 times the number of bikes sold. Now, if I take a look at the difference between the revenue and the cost, I'll get the profit function. So the profit function is P at X equals revenue in X minus cost in X. So the profit function is the revenue, which was 300 times X, minus the cost, which is the quantity, 100,000, the fixed cost, plus $100 per bike produced. So P at X will be 300X minus 100X is 200X minus 100,000. So let me box these because that's our answer for these. All right, so now more than how many units must be produced and sold for the business to make money? Well, to make money, your profit has to be good, greater than 0, right? So we're basically going to set P at X greater than 0. What was P at X? Well, 200X minus 100,000 has to be greater than 0. So if I add 100,000 to both sides, I will get 200x has to be greater than 100,000 dividing both sides by 200, we will get a result of x must be greater than 500. So let's answer the question. More than 500 units must be produced and sold for the business to make money. So basically, starting with the 501st bike, they start making money. All right? Okay, so if you want to pause the movie and try the next one on your own, feel free, or you can just work along with me. So here we are. You invested $30,000 and started a business writing greeting cards. Supplies cost 2 cents per card and you're selling each card for 50 cents. Let X represent the number of cards produced and sold. So our startup is good, $30,000, all right? So that's our fixed cost. So the cost in X will be $30,000 plus, how much does it cost to make each card? Good, 0.02 times X. So the revenue function, we're charging 50 cents a card. So that's going to be 0.5 is 50 cents plus, or no, not plus, times X. Write the profit function. Well, the profit function is equal to the revenue function minus the cost function. So the profit function will be 0.5 times X minus quantity 30,000 plus 0.02 times X. So the profit function in X will be equal to, so 0.5x minus 0.02x is going to be 0.48x minus 30,000. So that is our profit function. And we need profit to be greater than 0 to make money. Our profit function was 0.48 times X minus 30,000 has to be greater than 0. Adding 30,000 to both sides, we'll have I'm going to move it over here. 0.48x must be greater than 30,000. Now dividing by 0.48, might want to use a calculator for that one. I've got this one handy, so I'll go ahead and use this one. So 30,000 divided by 0.48, 62,500. So x must be greater than 62,500 to make money. So more than 62,500 units must be produced and sold for the business to make money. Okay, so that wraps it up for 9.1. I will see you soon, or you will hear me soon for section 9.2. Have a great day.